Yeah. Very good evening, my dear students. So I hope everyone had very good day today, right? At school. So today we gonna see one of the interesting topic. So we already done with this before. Do you remember? So let me first of all check my voice is clear. So give me a sec. Let me check. My voice is clear. Yes, my voice is super good. Cool. Okay. So here is what we are going to discuss today. So we are going to discuss differentiability. So last class we discussed about continuity, right? Actually, to be frank, last class, because of some issue, network issue and the technical part, we couldn't have that good session. So I got to learn many things from that session. Okay. So this session probably it's gonna very helpful for you guys to understand the topic. Okay. So the core idea of this topic is, give me a sec. So let me show you the slide. Yeah. So today we're gonna discuss differentiability. That is for KCET. Okay. The main agenda for this session is you are going to understand the core concept of differentiability. Even you are going to prepare for board, your 12th grade, or you are preparing for KCET, JEE, whatever exam it is. Differentiability, the concept will not change. In mathematics, so there is no limitation. How much you understood the concept clearly. So that much well you can confidently approach a question. This session is very basic session. So we are going to discuss from the core. I wanted to give you a deep understanding about the concept differentiability. So I assure that after this session, you will be having a very good clarity about this, about differentiability. So probably you will be having so many videos in YouTube and also in classes, you will be getting the idea what is the topic is. But particularly if you see in the session, we are going to understand the core concept. That's it. So wherever you go, you will be getting the concept, the main idea. I wanted you to understand it in a different way. So that we will discuss today. Without wasting time, we will move on to today's session. Okay. So anyone watching this video, you or after this lot, anytime if you're watching this video, try to put your comments in the comment section. Which standard you're preparing? So which exam you are preparing for, everything you put it in the comment box. It is helpful for me to understand my audience. Okay. So without wasting time, we will move on to the session. Differentiability. So already last class we discussed about what is continuity. So what is continuity basically? So the function, if it is continuous, we can say when there is no break or hold or jump in the function, in the domain, right? Okay. So what is differentiability? So differentiability is nothing but the differentiation of one variable, that is rate of change of one variable with respect to another. So what is differentiability derivative? That we will discuss. Differentiability of a function f of x at x is equal to a. So they are asking about differentiability of a function f of x at x is equal to a. First, you need to understand what we are trying to find. So your y is equal to f of x is a function given to you. So we have to find the differentiability of this function at x is equal to a. So coming to the definition part, what is derivative differentiability? So there are two variables you see. So this variable is actually dependent variable. So why it is dependent? It is dependent on x. That's why it is dependent variable. X takes any value from the domain, it is independent variable. So it is dependent variable, this is independent variable. And here I wanted to find the rate of change of one variable with respect to another at any instant. So that is dy by dx. So I'm finding the derivative of y with respect to x. But here we want to find the differentiability of a function at x is equal to a. At x is equal to b, a we are looking for. So that is f dash of. So whenever you are doing differentiation, you are finding the differentiability of one function with respect to another. So obviously what you are doing here, f dash of. So here at x is equal to a. So that is a. So f dash of a we are looking for. So graphically how it is. In physics you have a term. So we are finding the instantaneous rate of change of one variable with respect to another. So that is where, so d displacement with respect to t, that will give you velocity. What is velocity? Instantaneous displacement at a particular time. So what is acceleration? Instantaneous velocity change at a particular time. So that is what instantaneous rate of change of velocity at a particular time. That we are looking for. So whenever you have instantaneous rate of change, that is where differentiability of a function at x is equal to a comes. So here, let me give you a graphical representation of what dy by dx at x is equal to a or f dash of a says. So if I have y is equal to f of x function, okay. So here is a point. So that is the point. X is equal to a. So which is in the domain. So I want to find the derivative of this particular point. So rate of change of y with respect to x. So I'm going to consider a line like this. So the another point which intersects at something at a distance h. So this point is nothing but a plus h. So we are looking for the rate of change of one variable with respect to another. So that is dy by dx, which is nothing but y2 minus y1 divided by x2 minus x1. Here we are, this is a secant line. So we are not particularly finding the rate of change at this particular point, x is equal to a. So we are having a secant line. When I reduce this h tending to 0, this h is very close to this x is equal to a if I say. Then the another point which is here comes to very close to x is equal to a. So then the secant line slowly become tangent line. So we are looking for the tangent, slope of the tangent, right? So this is nothing but the slope. So we are looking for slope. Am I right? Exactly. So let's have a slide here. So let me draw the graph clearly. So here I have a tangent line. So this particular point is x is equal to a. So this is f of x. So what is actually f dash of a or dy by dx at x is equal to a mean? Let's discuss. So the limit, the h value is approaches to 0, or I can say the other point which is very close to a, right? So the other point x1 now. So that x1 is approaching a, I can say. So the x1 is actually approaching a. So we can have three different definitions for this f dash of a. So let's figure out what are those. So because in your textbook you have two different definitions. So you should not get confused with that. Whatever definition is in your book, that is same. Try to understand that. So whatever definition given in your book, so you should not select the definition part. So you have to understand as much as possible. Okay. So then only we can apply it in a different question. Better understand the definition. Limit h approaching to 0. So or I will be writing here, give me a sec. So let me erase this. Yeah. Okay. So now it works. Okay. So here is equal to a limit. So I'm going to take that x point, right? So that x point is actually approaching a I have taken. So f of x minus f of a divided by x minus a. What it says, the other point which is f of x, right? So that other point f of x is approaching, that x value is approaching a. So the here for x is equal to a, here the corresponding x values, f, y values f of a. Am I right? So that is f of a. So f of x minus f of a divided by x minus a. So whatever the value gives, that is nothing but the derivative. Try to understand this. Okay. So coming to the next point. Here I can introduce h also. Limit h here approaching to what? 0. So here I have this point. So we have to look for f dash of x. So this particular point, x plus h, no, the other point. So that h is approaching to 0. So the other point is a plus h minus f of a is the standard point. So x, that is nothing but a plus h minus a plus a minus a get cancelled. You will be having h in the denominator. So you will be having h in the denominator. Try to understand this clearly. I hope you understood. Am I right? Done. So now moving ahead. So anyone watching this video, if you want to have a conversation, you can like text to me if you have any doubts. Okay. So which is equal to. So these are the two important definitions. Sorry, here I did one mistake. So this is A. This is f dash of A. So it is not x. So we can generalize in terms of x also. Similarly, you can write f dash of x actually equals to, replace a by x. Limit h approaching to 0. F of x plus h minus f of a divided by h. This is the formula for derivative. So and also this. So now coming to your book definition. So if you see now, I think you can understand this clearly now. So there are two different definitions. This. So I have been, just now we saw that. So this is also the another way to represent f dash of c. So this is also f dash of c. Got it? Fine. Okay. So now we are going to see where the how to check whether the function is differentiable at a particular point or not. So what is the problem there to check whether the function is differentiable or not? So the existence of differentiability depends upon the limit. So here we have limit h approaching to 0, f of, so here I have f dash of x plus h minus f of x divided by h. So, or you can write this as limit x approaching to, wait a sec. Okay. X approaching to, x not approaching to x, f of x minus, no. Give me a sec. So here, the thing is limit x is approaching to x naught. But here we have x as the thing, now. This x, here you get x. So this is x naught, this is x. So make it clear. So since it is definition, however you want, you can write. So here I have taken different variables. To give a clarity better, I'll write as per the definition. Here it is. X naught okay. So f of x naught minus f of x divided by x naught minus x, limit x naught approaches to x. So this is the definition as per the previous slide. Getting my point? So now what happened to, how to check whether the function is differentiable or not? First thing, in order to say f dash of x exists, so we want to check the limit exists or not. Limit exists or not. If the limit, so this limit value becomes infinite or non-finite, not finite value, so then the function, then f dash of x does not exist. We can say f dash of x does not exist. So this is the first condition. If limit becomes infinite, give me a sec. Let me, okay. Let me put the chart. Okay, great. Fine. So this is the first case, if limit does becomes infinite. Second case, if limit does not exist, LHL and RHL, LHD, left hand derivative and right hand derivative, both are not equal, then the limit does not exist. And the third and most important condition, if f of x is not continuous. So if f of x not continuous, then I can say f dash of x will not exist at the particular point. So these are the things you need to check for. Getting my point at x. So when, if limit becomes infinite, that when you solve limit, if it is, you are getting infinite as the answer, so then it is not differentiable. Second thing, left hand derivative, right hand derivative. So what is left hand derivative, right hand derivative? So LHD is nothing but f dash of x minus. So which is limit h approaching to 0. Here the h value, no, it is neither, it can be either positive or negative, right? So it approaches from, can be that h value approaches to 0 from left side or right side, that doesn't matter. So since it is limit, So here LHL, if we are talking about, this H is actually positive. So it approaches only positive. Uh, it is actually positive value, which is greater than 0. Very small value, which is greater than 0. It was H definition here. So now f of x minus h minus f of x. You just replace plus h to minus h. So that is left hand derivative. So what about right hand derivative? So right hand derivative is nothing but f dash of x plus. So you can write this as limit h approaches to, I think whatever I am writing here you can't see. So in the last session also I felt my bad, I wrote most of the formulas here. So I try to avoid it in this session. So today we'll take a new slide. Yes. We will write R, D, R, H, T. Yeah. Fine. So here R, H, T. So it is right hand derivative. So what is right hand derivative? Limit h approaching to 0, f of x plus h minus f of x divided by h. So it looks as same definition for derivative. So here you can write f dash of x plus. So if these two values are same, I can say limit exists. So derivative, the function is differentiable at that particular point x. Got it? Okay. So now how to check it graphically, that we will discuss. So whenever you have a sharp edge like this, so if you have a sharp edge, or if you have a function like this, okay, so a function like this. So first thing here, if you see, it is not continuous. It is not continuous. So then this function is not differentiable. Look, here if you see, here I have a sharp edge. So that means here the slope is not gradually changing. That's the problem. So here left hand derivative and the right hand derivative is different in the neighborhood of x is equal to a. So the function cannot be differentiable at x is equal to a because of the sharp edge. So whenever you have a vertical slope, that is the limit value becomes infinity. So there also that derivative does not exist. So these are the cases that you should know. So I think I am clear with this. Differentiability. So this is what? Okay. So here we are going to solve question. Finding the derivative. Y will be given to you. So we are looking for dy by dx. For that we need to know some formulas. Standard formulas we have. So first let me explain you how you got the formula. So in physics you would be studying what is derivative. So in 11th standard itself you studied, right? So you know the basic formulas. So how we got that? Maybe some students would be knowing it's well and good, super good. But if you don't know, try to understand. So if dy by dx we want to find. So here the question is y is equal to sin x given to us. So what is derivative? Differentiation of sin x. The differentiation of sin x, we are with respective x, we are differentiating. Sin x becomes cos x. So here I have cos x. So how we are telling that sin x become cos x here. So how the derivative works? So we know that, right? So what is derivative? So dy by dx we are looking for. So the limit h approaching to 0, f of x plus h minus f of x divided by h. So this is what the value. Since sin x is continuous function, we don't need to find left hand derivative and direct right hand derivative for a particular point. We are generalizing the result here. So now limit h approaches to 0. In general, we will solve. So what is f of x? So anyway, f of x is nothing but sin x. So here I have sin x plus h minus, here I have sin x divided by h. So what it is? Limit h approaches to 0. So here we have a formula. What is the formula? Sin C. In trigonometry we have studied. So trigonometric formulas we use everywhere. Try to memorize all the formulas. I don't want you guys to memorize. Just understand the formula. With the help of sin A plus B, cos A plus B, tan A plus B and minus of it, you can derive any such any formula in trigonometry. Try to understand the formula and memorize everything. Okay. Sin C minus sin D. So what it is? 2 into sin. So this place is not enough for me actually. Let me erase this. Yes, hi. Good evening. The students who are just seeing the video, just tell me how the session is going. So could you able to understand? Yeah. So coming to this, sin C minus sin D is equals to what it is? 2 cos C plus D by 2 sin C minus D by 2. So this is the formula. So we are going to use that here. 2 into, so what I have? Cos. So I want to add these two. So 2x plus h I will get divided by 2. Similarly, I have sin. Sin. If I subtract, so I will be getting h only, no? H by 2. So whole divided by h I have. So here the problem is when h is equal, h approaches to 0. So we will be having 0 by 0 form. So what is the problem with this particular term? Sin h becomes 0. Sin h by 2 is 0. So denominator is also 0. So I wanted to make use of the property that you studied in your PU1, right? Yeah, let's look at that. So here I have cos 2x plus h. So here I have trigonometric function, the so-called very important formula is that limit. So I will write in different color here. Limit h approaches to 0 sin h by h. What it is? It is equal to 1, no? Yeah. So here if you see, I have sin h by 2. So divided by, in the denominator what I have? In denominator I have, so h. So this thing is h by 2. So I wanted to make that as h by 2. I am going to make use of this 2. So I am bringing that down, h by 2. So now it's super good. Limit h approaches to 0. So I have cos 2x plus h by 2. So here I have sin h by 2 by h by 2. So the value of this is 1. So what is the answer? Final answer. So that is equal to limit h approaches to 0 cos 2x plus h by 2. This is what we are getting. The next step. So what can be done? Limit h approaches to 0. Okay. Cos 2x plus h whole divided by, not whole divided by. Wait a second. Yes. Cos, what is here? 2x plus h by 2. So when I substitute h value equals to 0, so this become cos x. So that's how. So we have taken the given function f of x is sin x. So the derivative f dash of x we got as cos x. That's how we got the formula. I hope you guys understood, right? Fine. So now we are going to discuss some important formulas in this thing in differentiation derivatives. Before that, as the additional information, I wanted to give you some expansion that you should know. So it is additional information, but if you know this, you'll get to know the idea of some major function easily. Okay, so let's discuss that. So what is e power x? So you know e is actually Euler's number. E power x is nothing but 1 plus x by 1 factorial plus x square by 2 factorial plus x power 3 by 3 factorial plus x power 4 by 4 factorial. It will go like this. So if you want, you can simply write this as in summation. Summation of, so here r is equal to 0 to infinity. So what you get here, x to the power r divided by r factorial. So you can write it in summation like this. So even if e power x is like this, this is the expansion. In later class, I will be teaching you how we got this expansion also. This is not needed now. So we will discuss that later. Okay. So a power x. So whenever you have a power x, try to understand the base always greater than 0. So if time permits, I will be teaching you exponent also and the graph. It's very interesting concept, believe me. So as of now, since we are discussing about expansions, you should be knowing that a power x. So that a is base now. So this base has some important restrictions. This a cannot be negative. A cannot be negative. So it should be positive always. So a should be greater than 0. Why it is not equal to 0? It cannot be equal to 0. And it cannot be equal to 1 also. You guys, I'm going to give you one work, okay, or interesting work. You just go and research about it. Do research. Why the base a value is positive? Why it cannot be negative? Okay, so you try to get that, because if I say base as minus 1 to the power minus 1, so you have minus 1 only, no? So if my base is minus 1, there is no problem here. So why we are not having the base in exponent function as positive only? Why? Think. So why it is not equal to 0? Why it is not equal to 1? Try to understand. It's not, no, it's for, no, it's not for JEE. It is completely. So we are here to understand the concept, okay? So this is for your board, KCET and JEE. If you are looking for conceptual clarity, so this video is for you. I think I gave correct answer for you. So kindly tell your name in the comment box, right? So I can address you easily. Look, so this is what. So here we have a power x. So what is a power x? 1 plus x into log a divided by 1 factorial plus x log a the whole square divided by 2 factorial. Plus you can relate why I write a power x here. So you can relate with e power x, right? Yeah. So now these two information is this additional information you are learning is enough for today. Okay. So whenever I ask you what is e power x, this exponent should come to your mind, because most of the formula derivation we are using it. A power x, so this is the thing. Okay. Yeah. So moving on. So now we are going to, I'm going to tell you some set of formulas. Maybe you are already aware of it. Yeah. So we will move on to that. So here I'm going to give you what is y. So dy by dx, what is the corresponding derivative for that particular function we will see. So these are all basic, very, very basic. So we will start with trigonometric function because I like trigonometry. Sin x. So y is equal to sin x. So what is the derivative? If you know, put that in the comment box. Take your time. So cos x. So what is cos x derivative? Minus sin x. So you have to be thorough with this. What is tan x derivative? secant square x. What is cot x derivative? Minus cosecant square x. What is cosecant x? Minus cot x cosecant x. What is secant x? Secant x tan x. So all six trigonometric ratios, we have the formula. So the very important formula that you are already aware of. Very first time your physics teacher taught you this, I guess so. So comment that if you know this from physics, okay? X power n is equal to, the derivative of this with respect to x is n x power n minus 1. So additional information, if I have x minus a to the power n. So you can write that x minus a. So x is linear, x minus a, right? So again, we have to do the same. This thing, base, you have to consider as some variable. So the variable to the power n, that is constant if you have. This constant n comes to front. N x minus a to the power n minus 1. So this is your formula. Okay. So why? And then this base has to be differentiated. So x minus a, if I differentiate, I will be getting 1 only. So if I have x alone, I have x alone. So the derivative of x is 1. Because here I have power 1. So 1 comes to front. 1 minus 1 is going to be 0. Anything to the power 0 is 1. That's why 1. So when I have ax, some constant, here a is constant. So a being a constant multiplied with x. So I know x derivative is 1. So a will remain as it is. So when I have constant alone, a is a constant, no? So when I have constant alone, here there is no function of x. So which means I can take a into x power 0. So 0 comes front means it will become 0. So 0 is the derivative. So whenever you have constant alone, that is 0. So constant with some variables, that constant remain as it is, then you want to find the derivative of that. Okay, got it? Fine. So then what are the other formulas that you should know? So now we are going to like logarithmic and exponential function. So logarithmic function, log x I have. So here you see in your NCERT, or if you are looking like your Karnataka board book, if you see, so you don't have base. So if you don't have base, you automatically take that as E. But this definition in your higher class, you will be seeing differently. Whenever you have, okay, wait a sec. Here there is a power cut, guys. Give me a sec, give me a sec, give me a sec. Okay. Okay, I think now you can see me, right? Yeah. Okay, sorry for that. Here there is sudden power cut. Okay, we will continue with the class now. No issues. Okay. So the log, I think my voice is clear. Fine. Okay. I don't know whether my, okay. Okay. So the log base EX. So this is actually natural log, guys. Okay. So the log base EX is natural log. Okay. So natural log also can be written as ln. So when you see ln, you don't think this is something. So this is nothing but log base ex. So even base is not given to you, you consider that as e. This is as per your board. Getting my point? Done. So now this is 1 by x. So the log base e. So the log base a, if I have x. So what is the formula? So So whenever you have log base a, 1 divided by x. Log base EA. This is the formula. Okay. So when you have exponent function e power x. So when you differentiate e power x, it is e power x only. So when you differentiate a power x, the formula is a power x log, okay, a power x log a. So this is how we do. I hope these formulas you have to memorize somehow. Okay, fine. So now we are going to see, okay, so when I have function like this, there is a rule called, there are three important rules. Three important rules that you need to study. That is needed. Okay. So what are the three important rules in differentiation? So first one, chain rule. Second one, product rule. Third one, quotient rule. So if you are already aware of, it's good. So chain rule in your book, if you see, there is definition given like f of x, g of x, different functions. So you are taking g of x as some other variable t or something. So then again you are solving it like that. The definition will be. So but the thing is, you no need to like do take the other function as other variable. No need to do that. Okay. So instead of that, you understand how the approach is, how to take the problem. So let first I'm going to teach you how to use chain rule. Okay. So first here I'm going to teach you how to use chain rule. So chain rule is nothing but when to use. If I have sine x to the power 5, okay. So here the problem is which formula should I use? If it is x power 5, I can differentiate using x power n derivative formula. This is y given to us. So we want to find dy by dx. How can I figure out it? That's the question. Okay. So if x is equal, y is equal to sine x to the power 5 is given. So the base function is not x. If it is x to the power some constant, we can use the formula. So what we are doing is we are taking this as x. We are assuming that it is x. If it is x, what you do? So you will bring that 5 friend. So 5 sine x to the power 5 minus 1. So this we will do if this base is 5. But here that base is not 5. If the base is not x. So the base is sine x. So you want to differentiate that base which is not as in the standard formula. So you want to differentiate that also. So sin x to be differentiated. So the sin x differentiation is what? It is cos x. So the answer for the question is 5 cos x sin 4x. So this is the answer for the question, for this question. I hope you understood, right? So this is how you use chain rule. Even how much function you have. For example, another question, let me pick. So for chain rule, so y is equal to, okay, 6 tan log x to the power whole to the power 1 by 2. Okay. If I have like this, so if I want to find the derivative for this particular function. So as I told you before, so how much you have. So whatever function, whatever big function is given to you. So you wanted to use the same logic which I told you before. Okay. So let's do that now. Okay. So dy by dx 6 into. So since this is something different from x. So I have to consider this as x only. So that 1 by 2 comes front, 1 by 2. So the power tan of log x 1 by 2 minus 1. So which makes this is 1, here it is 3. 3 tan log x to the power minus 1 by 2. So I can write, look, so here I tried to simplify this. Look. So here I tried to simplify this particularly, but where is it? Where is it? Okay. So since it is different from x, we want to differentiate this also. So we differentiated this particular part. Here I have tan of log x. So tan of log x we want to differentiate. Tan x. So here I want to differentiate this. If it is tan x, I can differentiate. Here I have tan of log x. So tan differentiation is secant square. Secant square x. So secant square instead of x we have log x. You have to put log x here. So now, so which one is different? Log x. So log x again I want to differentiate, that is 1 by x. So here you will be getting secant square log x divided by x. So the final answer for this question is 3 into 3 divided by. So I can write tan of log x whole to the power 1 by 2 into. So here I have secant square log x divided by x. So this will be the answer for the question. I hope you guys understood. Yes, is it clear? Yeah. So now we will be moving to questions. So this is the direct question from your NCERT and your Karnataka board. So just look at the question, try to solve. Okay. So we discussed about chain rule. So most of the questions you have in the exercise is using chain rule, first exercise. So later then we are moving to product rule. Okay. So let me explain you product rule and quotient rule also. So that is not big deal. Okay. So better you try to understand that also. Then we jump into the question. So the product rule. Yes, when we apply product rule, as the name suggests, here you have product of two functions. So here I have two functions. U is equal to, U is nothing but function of x. V is also another function, which is function of x. So here I have two functions. So if two functions is in addition, first of all, let's talk about addition. U of x plus V of x. So if this is the function given to us, then they asking you to differentiate this. I'm taking this as y. So dy by dx is what? You just want to differentiate this and this separately and add it. You will be getting it. Even if it is minus, you want to differentiate and subtract it. You will be getting the derivation. So coming to product rule, that is the rule too. When two functions are in product, so you have to do this calculation. So UV. So when to use UV? So product of two functions. Example, if I have sine square x log x power 3 sine x. If you have this type of functions, here it is product of two functions. So I don't know the formula directly to differentiate this. I know sine, I know for log, I know for x cube, I know for sine, but I don't know for the combined function. So the product of both. So what do you do? UV, product of two. So if I want to differentiate this, d by dx of UV, what do you do? So you try to understand u dash v. So whatever it is, first differentiate the first function. U dash v plus uv dash. So this is the formula. So uv dash. If you want to differentiate, so you have to differentiate u first. Keep v as it is. U keep as it is. Then differentiate v. So this is the formula. So now this is product rule. What is quotient rule? So quotient rule, when you have function which is in division. So u by v. So if you want to differentiate, so what is the formula? U dash v minus uv dash divided by v square. So that's all. If you know all these formulas, you can easily solve differentiation questions. Okay. So now since it is very basic, we are just understanding the basic level core. So we are solving questions from your NCERT and some questions of higher level. We will solve. So let's look at the questions now. So this is the chain rule definition given in your book. So if you see that, it's quite confusing, but if you look very carefully, whatever the explanation I gave, that is this. Okay? Fine. So now, so what is secant tan root x? So you see here, so this question can be solved using what? Chain rule. Am I right? Fine. So y is equal to secant of tan root x. Okay? Yes. So what is dy by dx? dy by dx is equal to, so differentiate secant. Secant is secant of tan root x, secant tan of tan root x. So differentiation for secant is secant x tan x, right? So this is how you get. So now tan root x, I want to differentiate. Tan differentiation is secant square root x. So now I want to differentiate root x. So if I differentiate root x, so what is root x? X to the power 1 by 2. So 1 by 2 comes from x to the power 1 by 2 minus 1. So which is minus 1 by 2. So I can write secant tan root x tan of tan root x secant square root x whole x to the power minus 1 by 2 whole divided by 2. In the next step, you can take this 2 down as root x. So like this you can write. So this is how you use chain rule. So try to solve more questions. So this question we will be solving using chain rule, right? So I hope this one you can do. So now we will solve this fifth question. So how to solve this fifth question? I have sin ax plus sin ax plus b divided by cos cx plus dik. Yeah. Okay. So this is y. So we want to find the derivative. dy by dx. What it is? So uv method. So u by v. So y is equal to u by v. So if you want to differentiate dy by dx, what is the formula? U dash v minus uv dash divided by v square. So we will use that. What is sine? Sine differentiation is cos. Cos ax plus b. So this cos cx plus d will remain as it is minus. So sine ax plus b will remain as same. Cos differentiation is minus sine, which is plus sine plus sine cx plus d whole divided by cos square cx plus d. So if you want, you can simplify this further because I have cos square cx plus d in the denominator and also numerator I find 1. So you can take this to cos ax plus b cos cx plus d divided by cos square cx plus d plus sin ax plus b sin cx plus d divided by cos square cx plus d. So cos cx plus d get cancelled. So here nothing to cancel, but we can change in terms of tan and secant. So now cos ax plus b. So this is secant cx plus d plus sin by cos. So here sin ax plus b as it is. I can write tan cx plus d. So here I can write as secant cx plus d. If you want, you can take secant x common out. So this is how you solve. So look guys, this simple it is, the derivative, right? So if you know the concept. Got it? So now we are going to solve some questions. So before we are moving to differentiation concept, derivatives. What are the subtopics? What are the topics we are going to discuss in this particular chapter? We will have a outline first. So give me a sec. Okay. So now this is the overview or outline of differentiability. Continuity and differentiability chapter in NCERT. Continuity and differentiability. So first we discussed about the definition of differentiability. Second, now we discussed about derivatives, basic formulas, rules we discussed. So after this, we are going to see function, that is how to differentiate exponential and logarithmic functions. So here we will be seeing how to use log to differentiate complex functions. Complex function is given to you. How to use log to get answer. Okay. So we will see that logarithmic differentiation. So and we will be discussing derivative of a function in parametric form. Of a function in parametric form. At last, so higher order derivative. Higher order derivative we will discuss, and we will discuss some of the important theorems that we have here. So intermediate value theorem, so Rolle's theorem, and mean value theorem. So these are the things we will discuss in differentiability concept, derivatives. Okay. So after this, we are going to see one of the very important topic, that is application of derivative. So that we will discuss soon. Okay, give me a sec. Okay, guys. Fine. So I guess prove that the function f is given by this. So if you are looking for competitive point of view, so I will not solve this question using limits and all. What instead I will do? So I will just draw a graph. So how to draw f of x is equal to modulus of x minus 1. So when you have so this is y is equal to mod x graph. But I have y is equal to mod of x minus 1. Since it is minus 1, we have to move right side. So right side, this function should be moved right side by 1 unit. Okay. So this is y is equal to mod x minus 1 graph. So if you look at the graph at x is equal to 1, the slope changes drastically. This function is continuous everywhere on the domain. But this function is not differentiable at. It is not differentiable at x is equal to 1. So what is the problem? So I can write f of x is equal to, whenever mod function is given, so you can break the function as x minus 1 minus x plus 1. So here when x is less than 1, sorry, greater than 1, here x is less than 1. So these are the cases, right? Fine. So now if you want to find the derivative, dy by dx, so you can use here only. So I will be having 1. If I differentiate this thing, so I have 1. So if you want to, you can do in this, or like you can use limit also. So for I wanted to you to solve in this method, because whenever 1 mark in, or MCQ is given to you, so your approach should be like this. So this is for x greater than 1. So for x greater than 1, your slope is actually what? 1. So where x less than 1. So that is at the particular point we are looking for. So if I differentiate, so the slope will be actually equals to minus 1. Okay. So left hand derivative and right hand derivative are not equal. So I can't say, I can say that this function is not differentiable at x is equal to 1. And also it has shortage according to the diagram. Getting my point? Yes. So now we will be solving some questions. Give me a sec. Let me open questions. So to be frank, differentiation is actually one of the easy concepts. Calculus part is a high weightage topic actually. So whatever exam you take, JEE, it is high weightage. KCET, it has high weightage. Even in your board, it has good weightage. So even 5 marks and almost of the 5 marks you are getting from this particular topic only. So try to understand the importance of calculus. What happened? Try to understand the concept and do it wisely. Okay. So what happened? Okay. Now it's fine. Okay, moving on to the next slide. Okay, so these questions are KCET PYQ questions in continuity and differentiability concept. So I have these questions also. We will solve this soon. So before that, I want you guys to solve question in derivative using the formula. You know what is the derivative for exponential function and logarithmic function. So we will solve some questions in that topic. Okay. So here is the question. So I'm giving questions directly from your NCERT. Okay. So if you feel like you able to solve it, pause the video, solve it and check with the answer. So now here the question is, first one. When e power x divided by sin x. Okay. So you want to find the derivative. It's very simple question, UV method. So I know d by dx of e power x is actually equal to e power x only. So we are going to use that. So now what is the formula u by v? So we are going to differentiate. Let this be y. So y is equal to e power x divided by sin x. So what is dy by dx? dy by dx is equal to, so differentiate e power x, sin x remains as it is, minus e power x remains. Sin x differentiation is cos x divided by sin square x. That's it. That's the answer for this question. It's simple, right? So yeah, different question we will try. So here there is one third question in your book, that is e power x power 3. Okay. So just for practice, you work out these questions. You will get a good clarity. Dy by dx is equals to. So what is the differentiation? E power x differentiation is e power x only. So here I have e power x cube. So here I have x cube, which is not x. Instead of x, I have x cube. I want to differentiate x cube. So chain rule, we are using that same here. So 3 into x squared. That's it. So the answer will be 3x squared e power x cube. That simple it is. So they won't ask you direct question. So they will be asking you application. While solving, you have to apply this. Yes, exactly. So let's solve one more question. So when the question is asked like this, root of e power root x. Okay. So if this is the value, this is the y value, y expression. So how to find dy by dx? So first of all, this is nothing but e to the power root x whole to the power 1 by 2. So since x power 1 by 2, how I treat? Same thing you have to do. So 1 by 2 e to the power root x whole to the power minus 1 by 2. Now into. So now I want to differentiate e to the power root x. So e to the power x differentiated as e to the power root x only. So root x is, you have to differentiate root x. So 1 by 2 x to the power minus 1 by 2. So try to simplify this. 1 by 4 e to the power root x minus 1 by 2. So here I have plus 1. So now x to the power minus 1 by 2. So I can write this is root of e to the power root x divided by 4 root x. That's the answer for the question. I hope you guys understood, right? So now we are going to see logarithmic differentiation. So when the function has log in it, so you know how to do log. So yeah, we will do logarithmic differentiation. Wait. So before that, log of log x is given to you. So how you solve this? How to find the derivative of this? D by dx is equal to 1 by log x differentiation is what? D by dx of log x is nothing but 1 by x. So log of log x is nothing but 1 by log x. So again, instead of x, I have log x. I want to differentiate log x is 1 by x. So the answer is 1 by x log x. That's it. Okay, whenever you have exponent function or logarithmic function, try to approach in this way. Okay. So when you have y is equal to 2 to the power x, I already told you a formula. D by dx of a power x is equal to. So 1 minute. D by dx of a power x is equals to a power x log a, I said. But if I don't know the formula, what should I do? What should I do? So you should know some of the properties in log. You are already aware of it, some of them. Otherwise, don't worry, I will be teaching you that. A power x, something like a power x. So if you just want to write it in terms of base e, so I want that base to be e. If I have just number 5, so I want base to be e. So what can I do? E to the power log base e5 I can write. That is the property. What is the property? I have some A can be written as e to the power log base e to the power a. So this can be written as like this. So base log base e, and if the base is e, it will give a as the answer. So I'm not going to touch the proof. So this is a property, just you understand. Got it? Yes. So now, and also we have another uh, format. Whatever base a is, if you want, you can change the base to 10 also. So if I have a power x, so I want the base to be 10. So what I can do? So I can write this as base 10 log base 10 a to the power x. So like this you can do however you want. So if base is e, I know the formula I know the formula e power x is equal to e power x only. So here this can be written as e power log base e to power x. Getting my point? So, and also we have a formula log base something e, a to the power n is nothing but n log base ea. This is also true. So that property I'm going to use. Okay. So e power x log base e2. So this log base e2 is nothing but a constant. There is no variable. So now I'm going to differentiate this. dy by dx is equal to what? E power x will be the same. E power x log base e2. So now x log base e2 has to be differentiated. So I will be having x differentiation is what? 1. So log, you have, this is constant only. Log base e2 is constant. So you will be having this. So what is this? Again, I am using the same property. I will be getting 2 to the power x. Log base e2. So this is the exact formula we got before. Right? So if you know, with the help of these properties only we derive this formula. So I just wanted to tell you guys. That's it. Okay. So coming to logarithmic differentiation. Since we are up to logarithmic differentiation, you should know what is logarithm, what are the properties of logarithm. Okay. So let's discuss some of the properties in log. Let's discuss that first. Very first property is log base e base a to the power m if I have. So the answer is m only. We know log base a is equal to 1. So whatever the power is. So the main logic for log is whenever you have log base a x. So you are trying to write this x no in terms of a to the power something. A to the power something. That's something power now. That is the value of log. Try to understand this definition. So log base ax. So whatever the input x you are getting, that x you are trying to write it as the base a to the power some power, a to the power something. That power will be the answer. Getting my point? Yeah. So, and if you, second property, third, when you have log base a, b to the power m. So the answer is m log base a, b. So when I have log base a, b plus log base a, c, the value will become log a base b, c. So each and every properties have its own proof. If you are interested, try to Google it, research it and find the proof. That is also interesting. I don't want to take you to the definition and what proof part. So I will be giving you the properties. Better you find the proof. If you need proof, I will tell me in the comment. I will be giving you the proof in upcoming sessions. Yes. Good, great. So tell me in the comment box, okay? Fine. So fifth property. So when I have log base A B minus log base A C is equal to log base A B by C. So nothing but you can derive it very simple way to give a clarity. In order to make it plus, minus 1 comes to the power, right? So this can be written as plus log base A 1 by C. So then you are using the property of product, you will be getting this. That's it. So now, okay, so these two are important. Sixth one. So here the change of base. This is very, very, very important. So when you want to change the base, so I don't want the base to be A, I want the base to be E. Okay, so what can I do? So natural log. So I am putting BE here. Okay, so log base E B divided by log base E A. This is how you do. Getting my point? Yes. So this is change in base. You need to understand. Okay? Yes. Now, we are going to see how to use logarithm for complex differentiation. So something like if I have example, root of x minus 3, x squared plus 5, x minus 1, x minus 2, x minus 3. Okay? So if I have like this, the function is like this. Y is equal to this is given to you. And they asking you to find the derivative. Find dy by dx. So how will you do this, guys? How will you do, guys? It looks very complex, no? So to the power 1 by 2, I have x minus 3 into x square plus 5 divided by something, some big expression, u by v if you do. So how to differentiate that x minus 1, x minus 2, x minus, if you have to multiply. So it looks difficult. So whenever you have some complex expression in terms of product or division, you have to use log. I will tell you how to use it. First of all, try to understand where to use. So when you have a function is like this, you can use here. If your function is y is equal to cos x to the power x cube I have, I don't know. If the power is something constant, I can use the formula, derivative formula x to the power n d by dx. I can use this if power is constant. Here I have power again a function. I don't have a special formula here. I want to bring that down, right, in kind of product. So here I can use log. So whenever the function f of x to the power g of x you have, so try to use logarithmic differentiation. So whenever you have y is equal to some function f of x, here you have product of more than two functions, product and division of more than two functions. Try to use this. Try to use same logarithmic differentiation. Okay, how to use this? Let me explain what is the procedure. So y is a function given to you. So let me take a one question and solve it for you guys for a better understanding. X minus 3 into x square plus 4 divided by 3x square plus 4x plus 5. Let me take this. This is with respect to x you want to differentiate. So our ultimate aim here to find what? Here to find dy by dx. Okay. So since the function is quite complex, I'm going to take log on both sides. Okay. I'm going to take log on both sides. So log y is equals to log of x minus 3, x square plus 4, 3x square plus 4x plus 5 whole to the power 1 by 2. So now I can use the logarithmic property. Okay, I can use the logarithmic property 1 by 2 log 1 by 2 log x minus 3 into x square plus 4 divided by 3x square plus 4x plus 5. So this you will get. So now it is, you can differentiate. Before differentiating, again we are using the log property. So this can be written as 1 by 2 into log. So I am putting a bracket here. X minus 3 plus log x square plus 4 minus log 3x square plus 4x plus 5. This you can write. So now we are going to differentiate. So differentiate with respect to x. With respect to x. So 1 by y dy by dx is equals to 1 by 2 into. So this is 1 by x minus 3. So x minus 3 differentiation is 1 only plus 1 divided by x square plus 4. So x square plus 4 differentiation is 2x minus 1 divided by 3x square plus 4x plus 5 into 6x plus 4. Got it? Yes. So we got this. 1 by y dy by dx. So we want to find dy by dx only. So in terms of x, keep that in mind. Okay. So try to write y. Y is what? Root of x minus 3 into x square plus 4 divided by 3x square plus 4x plus 5. So here I have 1 by 2. Keep it there only. 1 by x minus 3 plus 2x by x square plus 4 minus 6x plus 4 divided by 3x square plus 4x plus 5. So you think, guys, if you are solving it in normal procedure, how long it will take? How long it will take to solve? So if you use logarithm, it's simple to solve. So that's why we are using logarithm. Getting my point? Yes. So now we will be solving one question. Okay. So differentiate y is equal to, differentiate this expression, log x to the power cos x with respect to x. So here we have a solution. So what is the solution? So y is equal to log x. I told you, no? So whenever you have y is equal to f of x to the power g of x. So you are supposed to do, take log on both sides. Why we are doing that? To bring that g of x in terms of product. Yeah. So taking log on both sides. So if I take log y is equal to cos x log of log x, I get. Getting my point? Done. So what can be done now? We can differentiate directly. Differentiate with respect to x. 1 by y dy by dx is equal to, so cos x differentiation is minus sin x. So the log of log x will remain as it is plus cos x, log x differentiation is 1 by log x here. Again log x differentiation is 1 by x. So try to write this cos x divided by x log x minus sin x log x. Okay. So dy by dx is what? Y into, what is y? Log x to the power cos x into cos x by x log x minus sin x log x. So this is the answer for the question, dy by dx. Very simple if you solve it, right? So in your book, there are some questions with two different functions given like this. For example, I'll take your book question and tell you, you have to try that. Okay. So the log base x. So most of the students are getting problem in this. I don't know why they are getting problem here. So here this is why. So I told you whenever f of x and g of x to the power is given, so you want to use log only. Here two different function is given. If you take log for the entire term, you can't take something in front, right? So don't do this mistake, blunt mistakes most of the students do. Log of a plus b is equal to, they do something and write it in product. So who told this? Who told it is true? It is bullshit. You should not do that. So what can be done? So here, so you want to take this as y1, this is y2. So try to find out what is dy by dx is nothing but dy1 by dx1 dx plus dy2 by dx. So try to find dy1 by dx. So how can I find that dy by dx? Y1 is equal to log x to the power x, no? So try to differentiate, try to put log. Log y1 is equal to x into log of log x. Right? Try to solve this. Try to find dy1 by dx. Similarly, y2 is given to you x log x. So try to bring that. Try to take log y2 is equal to log x, log of x. Okay, so you can put this like log square x and differentiate, try to find dy1, dy2 by dx. Substitute it here, you will be getting the answer. That simple it is. So try to solve question in smart way as much as easy possible. If you find something common, take that common out. Don't struggle with that inside the expression. Okay, so let's solve one more question in this topic. So let's have so good evening everyone. Yeah. So now let's have one question. Give me a second. Let me switch. Yes. So this is one big question. Okay. Let me write the question. Find dy by dx if y to the power x plus x to the power y plus x to the power x is equal to a b. So this is given to you. Okay. So now I have these many things. So I want to differentiate. I want to find dy by dx. So can I do that? So I will figure out from this expression if this is given like this. So dy by dx we want to find. So try to find what is. So let me take this as u. U is equal to y to the power x. So v is equal to x to the power y. So u, v, w. What is w? X to the power x. So what you do? So first let's try to solve what is dy by this. So first differentiate this. What is du by? Yeah, wait a sec. So I will write the function as u plus v plus w. So I substitute it. Substitute substituting the values in given function, given expression or equation a to the power b. Okay. So I'm planning to differentiate this. So if I differentiate, what I get? du by dx plus with respect to x, dv by dx plus dw by dx. So here, since there is y, so we have dy by dx here. So that I am going to find. So I wanted to figure out this. Okay, guys? Fine. So what is u? Du by dx. So here u is equal to y to the power x. Taking log on both sides. Log u is equal to x log y. So whenever you have two different functions, so you are differentiating with respect to x. So when I have log u, so 1 by u du by dx, which is equal to, so here I have two functions multiplication, uv, product rule. So when I differentiate x, I have log y only, plus when I differentiate y, so dy by dx will come. So I kept x as it is, and I am differentiating log y, 1 by y, dy by dx, because I am differentiating with respect to x, right? So whenever you differentiate x, there is no need to put dx by dx. It's one only, no? That's it. Okay. So what is du by dx? Which is equal to u into log y plus x by y dy by dx you get. So du by dx is nothing but yx into log x plus x by y dy by dx. That's it. Similarly, I wanted to find v. So what is v? V is equal to x to the power y, I guess. Let me look. Yeah, exactly. So what is log v? Same. So log y comes front, log x, differentiating 1 by v, dv by dx is equal to, so y differentiation is dy by dx, log x will be as it is, plus y log differentiation is log x is 1 by x. So dv by dx is nothing but, what is v? X to the power y into log x dy by dx plus y by x. So similarly, I am finding for x to the power x, that is w. So taking log on both sides, log w is equal to x to the power log x. Sorry, x into log x. 1 by w dy by dw by dx is equal to log x plus x by x1. So which is equals to 1 plus log x. So now we want to write. So what is dy by dx? Finally, dw by dx is actually equal to w, which is x to the power x. So in one step, I try to write. Okay, that's it. So now du by dx plus dv by dx plus dw by dx is equals to 0. So what is this value? So du by dx is nothing but y to the power x into log x plus x by y log dy by dx. Sorry, dy by dx. So I guess I can write it down because there is no space here. Anyway, if I write at the corner, you can't see, na? 0. So try to write it. So y to the power x into log x plus x by y dy by dx plus x to the power y into log x dx, log x dy by dx plus y by x, y by x. Okay. So then x to the power x into 1 plus log x. So I just wanted to take all the values which is independent of dy by dx. dy by dx coefficient and others. So dy by dx is here y to the power x, x by y plus x power y log x. That's it. Which is equals to minus x to the power x 1 plus log x. Okay. So and minus y to the power x log x minus x to the power y, x to the power y, y by x. So you just simplify. I'll write the answer here. Okay. So what is dy by dx? So dy by dx is equals to minus, if you want, you can take common out. X to the power x 1 plus log x plus y to the power x log x plus x to the power y, y by x whole divided by y to the power x, x by y plus x to the power y log x. So this is the required derivative. So which you see in the book. It is kind of how much page? It is 2 page, 2.5 page probably the derivation will be. So I hope if someone teach you this, you find it easy, right? So come on that, you just check with your book and tell me. So I have, in board exam board point of view, they won't ask you direct question from your book, but the concept is same pattern, same type of questions they are asking, just changing the value and they are giving. If you are well versed to solve this, it's easy for you to approach the question in exam. So some questions are there. So I will be giving you some questions. So you are going to practice that. Okay. So and if you're able to solve that questions, tell that in the comment box whether this session is helpful for you to solve other questions in your book directly. Okay. So here in our exercise, try to solve the question. X cos x to the power x plus, so plus this actually comes down plus x sin x to the power 1 by x. So here you have x cos x. If you want to differentiate this, you have to use UV formula. So use that. This is one question. So try to solve this question also. X to the power x cos x. So differentiating. So you want to find the derivative. So here you use, here it is minus actually. So here you use derivative. So here you use quotient rule. So x square minus 1. Here you use quotient rule. Here you use logarithmic differentiation. Try to find the value of this. So here you want to find the derivative. Find the derivative. The given function. Given function with respect to x. Okay. Try to solve this. And try to find dy by dx in the equation. So like this. Previous one I did as equation. So this is equation is given to us. Then we found the derivative. Similar approach you want to use to solve this question. So that is 2 questions I will be giving you. First one is x into y is equal to e power x minus y. The second question is cos x to the power y is equal to cos y to the power x. So try to solve this question. Okay? Yes. So try to solve this question. If whether this session is helpful for you to solve the question or not, don't forget to comment in the comment box. So I have some questions. So these are all PYQs in KCET. So just we will look at some of the questions, how to solve this and all. So here you have x mod x. So what is x mod x? So if you find modulus x, so x modulus x is, you want to write this as like stepwise function. If x is less than 0, it is minus x squared. So you have to replace modulus x with minus x. If x is greater than 0, so you want to write it as greater than or equal to 0, it is x squared probably. So the graph something looks like, so y is equal to x squared. So this one. So here this is the parabola. So this is for plus x squared. Then when it is minus, then you have to put the graph like this. It is minus x squared. It is plus x squared. So the function is continuous at x is equal to minus 1 to plus 1. Okay. So and it is it differentiable? Yeah, it is differentiable. So no issue in that. Okay. So this function is continuous and differentiable. Let's figure out each and every function. So here x can take any value. So since they are talking about only minus 1 to plus 1, we are looking at that only. So minus 1 to plus 1. So whether the function is differentiable or not, we are checking. So the root of x squared. So the output here you will get is the root x. Y is equal to root of modulus x squared. So modulus x, which is nothing but. So y always positive. So y is equal to give me a sec. Okay. Y is equal to x square graph. So I try to square on both sides. Okay. So squaring on both sides, y square is equal to x. Sorry guys. So y square is equal to x modulus x. So here this is what you get. The graph. Something looks like this. So if it is minus 1 also, it will give plus 1. Okay. So the graph something looks like this. Okay. So when it is minus 1 to plus 1, the function is continuous, but it is not differentiable. Why it is not differentiable? Here you find a vertical tangent. So that's the problem. Sharp edge also you can see. So that's why it is not differentiable at x is equal to 0. So this is not differentiable at x is equal to 0. So coming to x plus greatest integer function of x. So and this modulus of x minus 1 plus modulus of x plus 1. So let's look at that. So here I have, so since the function is talking about from minus 1 to plus 1. So we will solve in that way. So x plus greatest integer function of x. So here you see the integers. Minus 1 to plus 1. So minus 1 to 0. Okay, if I have values between. So minus 1 to 0. So greatest integer function is minus 1 only. So x minus 1. Right? Fine. So when a value of this is 0 to 1. So when it is 0 to 1, open bracket. 0 to 1. So the value will equals to 0. So x1. So how to draw the graph? If you draw the graph off of the problem done. Okay. So when 0 to 1. So y is equal to x is the function. So when the function is x is equal to y is equal to x minus 1. So when x is equal to 0, y is equal to minus 1. So here you get, right? Minus 1. When x is equal to 1, is minus 1. Okay, why I am looking at that? Fine. Okay. It's increasing. So when x is equal to minus 1, what is the value? When x is equal to minus 1, it is minus 2. Y is equal to minus 2. So here I can plot. And at 0, it is minus 1. When x is equal to 0, it is y is equal to minus 1. So here I get. So here I have a hole. So this is how it is. The function is not continuous. The function is not continuous. Then what to bother about differentiability? If it is not continuous, it is not differentiable also. At x is equal to 0. So that's the thing. So coming to this, modulus of x minus 1 plus, I try to write in the same slide because we wanted to refer with left and right side. So modulus of x plus 1. So this is, so whenever you are given with this kind of function, so here you have modulus and you want to look at the critical points. X minus 1 you want to equate to 0. X is equal to plus 1. 1. So x plus 1 is equal to 0. X is equal to minus 1. Place it there. So at different interval, the modulus of x minus 1 and x plus 1 take positive, negative, depends. So we wanted to figure out how the function behaves. So I guess you can't see here, right? So let me erase and show it at top. So anyway, I have noted everything. So you don't need the function here. Let me erase this. So within 5 minutes we will complete, guys. So I think the session is taking long than I thought. Okay, so look, here I have modulus of x minus 1 plus modulus of x plus 1. So we have a number line. So where it is minus 1 plus 1. Okay, so this function, how can I write? That's the question. I need some space. Okay. So here is a number line. So I have minus 1 plus 1. So the first box corresponds to the sign for this particular modulus function. So for the second one, this first one, second one, first one, second one. I will change the color also if you want. So pink. So I'm checking the sign of this. Okay, done. So here, if you see, both are negative, right? So if I see here x plus 1, okay, so x plus 1, when I put the values like 0, so here it is still negative. So but here it is positive, right? So now here both are positive, so which is equals to, so I can write this as when x belongs to minus 1 to, sorry, minus infinity to 1, minus 1, minus infinity to minus 1, minus infinity to minus 1. Both are negative. Minus x plus 1 minus x minus 1 minus x minus 1. So when x belongs to minus 1 to plus 1, so this is minus x, no, yeah, minus x plus 1 plus x plus 1, so which is 2. So here minus 2x when x belongs to 1 to infinity. So here we have x minus 1 plus x plus 1. So we will be having plus 2x. So if you look at the graph, in general I am telling you, if you look at the graph, minus 1 plus 1. So here it is 2x. So when x is equal to minus 1, so I have to put minus of minus plus 2. So automatically here it is plus 2. So here is also plus 2. It looks like a boat. Looks like a boat. So here you have 2. So this is y is equal to 2. So here this function is y is equal to minus 2x. So this is y is equal to plus 2x. You just cross check. Your slope is negative. So your slope is positive. That's it. So here we are looking at minus 1 to plus 1. This function is differentiable in the entire value, right? So that's it. So coming to this, the function is strictly increasing in the interval. Yes, the function is strictly increasing. Goes for this. First option here. The function is not differentiable at least one point in the interval. So the function is differentiable and also, the function is differentiable and also continuous here. So the function is not differentiable. So we can have these two options here. So so depending upon the given criteria, we can map everything. So we understood the nature of the graph. So we understood where this function cannot be differentiable at this particular interval. Everything we understood. So depending upon those conditions and the interpretation, you can map the correct answer. So I hope this question is easy and you understood, right? So in the next session, we will be continuing with the rest of the question since it is basic. So we have done most of the basic questions, right? So I hope this session is if you are new, if you are learning differentiability for the first time, this session is helpful for you guys. So you wanted to work out each and every problems from your NCERT, then slowly move on to KCET problem, then come to JEE. So don't separate all these exams in mathematics if you are preparing for all three. Everything you want to understand the concept. That's the only one mantra. I hope this session is easy and you understood. So tell your comments in the comment box. I'm waiting to read your comments, guys. So that help me to guide you or help you in a better way. I hope for the next session. So tell me in the comment which topic you find it difficult, what topic you want me to take and teach. I will be coming up with that topic. Okay. So stay tuned. Put like for more such videos and subscribe our channel. So that's all for today's session. See you all in the next interesting class. Bye bye. Hope you are doing good.